So welcome students. In this question, you're given that in a shop, 5 different types of ice creams are available. Now, the number of ways in which a child can buy 6 ice creams is NTSE 5, that is the first statement. And the number of ways in which the child can buy 6 ice creams is same as the number of ways of arranging 6 A's and 4 B's in a row. So, the first statement says that number of ways of buying 6 ice creams is NTSE 5. And the second statement says that the number of ways is equal to the number of ways in which I can arrange 6 A's and 4 B's in a row. So in how many ways can I arrange 6 A's and 4 B's in a row? There are a total of 10 objects. So 10 factorial divided by all the 6 A's are same. So 6 factorial. All the 4 B's are same. So 4 factorial. That is nothing but NTSE 6. So effectively the statement 2 says that there are NTSE 6 ways. Statement 1 says that there are NTSE 5 ways. So you just need to decide how many ways can I buy 6 ice creams. So there are 5 different types of ice creams. I have to buy 6 of them. So let me say that the types of ice creams are type 1, type 2, type 3, type 4 and type 5. There are 5 different types of ice creams. Now I buy x1 of type 1 ice creams, x2 number of type 2 ice creams, x3 number of type 3 ice creams, x4 number of type 4 ice creams, x5 number of type 5 ice creams. Assume that I have bought this. So the sum of these has to be equal to 6 because I have bought 6 ice creams. So now in how many ways can I make x1 plus x2 plus x3 plus x4 plus x5 is equal to 6? So effectively I want the non-negative integral solutions, right? Integral solutions, because x1, x2, x3 so on are the number of ice creams of a particular kind. So they can be 0 but they cannot be negative. They have to be integers, they cannot be fractions. So how many non-negative integral solutions are there to this equation? So this comes under the topic of beggar's problem. So what is the formula for this situation? N plus r minus 1c r minus 1. That is equal to 6 plus 5r is the number of types, x1 plus x2 plus so on up to x5. R is 5. Minus 1c, n plus r minus 1c, r minus 1. R is 5 minus 1. That is equal to NTSE4, or this is same as NTSE6. So the actual number of ways is NTSE6, not NTSE 5. So the first statement is false and the second statement is true. That's the answer to this question. Thank you.